Actually, yesterday we mentioned dropout, and it's uh, kind of well explained in many popular articles. I want to share the link to one of them. Of course, you can see Wikipedia page for that, but it isn't informative enough. Actually, do you know what is Wolfram Alpha? Have you heard of that thing?
Yes.
Do you know that under the hood in this in its search engine, they have really smart AI. It's not only natural language processing; it is also like knowledge-based system analytics. They don't have any article in their system at all. This is not Wikipedia that has predefined pages. Wolfram Alpha search engine doesn't contain any page inside. Instead, it contains many nodes with facts, and when you perform requests, the page is generated during the search process. Unfortunately, Wolfram platform isn't really popular now. It's because of availability of many open source tools, including Python universe. So we went through. Let's take a look at. Yeah. So we can see that at certain point we stopped getting any improvements. If we train further, this will become even worse, and we will get validation accuracy uh, going down. And this is why we needed to stop here. About epoch number 10, we got overfitting. For training set, it still goes down. It cannot uh, go up. But for validation, it is like starting to grow from 10. So now we can just experiment with dropout here. We need to redefine model object again. Let's copy dropout. Button. The authorization page open. Lost the page. Okay. Wanted to have it opened by this window. Here. A little bit weird. Page has gone somewhere. Okay. Let me reopen it. Let me reshare it in a minute. I understand. I get to make a copy. Simply. Works not as fast as I wished. It is free of charge, but sometimes it is like too slow. It dedicates different types of containers and sandboxes for different notebooks in some random way. And this means that sometimes we get a very weak platform dedicated for Jupyter Notebook we're familiar with. Google Cloud Solutions allows, like the platform allows to run your own cloud, like Google Colab, for company needs. So if you use Google Solutions, Google Cloud, you can also have a professional version of Jupyter Notebook hosting dedicated for your project. You can run their powerful GPUs and so on. So I want to add additional dropout layer and run it together with you again.
Can you share your screen?
Yeah, just a moment. Like technical issues here. So I'm adding just one line with dropout, and let's compare with previous. Oops, sorry. And we are going to train more than 10 epochs. Let's say 25 again. I recreated the model object because we don't need to have weights that are already trained. We want to start training, sorry. Some oh, okay, need to relaunch runtime. Sometimes it is impossible to go further without relaunching of runtime, but it is not very long time. So this is our first neural network, but with added dropout. And now we will see when overfitting is going to happen. Maybe we won't be able to achieve better result, but overfitting will probably appear later. That's right. Here. Where is the arrow? Oh. So you guys need to reinitiate this process. Let me share the screen in a couple of minutes. Mm. Too many sessions. Well, let's see what's going to happen on 25. A little bit more epochs.
I was not able to finish run this file.
Why?
It was running for a long time, and then finally it was disconnected.
Actually, entire file was computed on collab, so you definitely can run it. Please check if GPU is selected for your environment, first of all, and try again,
Yes.
please.
It's Python 3 GPU.
I mean, in option, like runtime type here.
Yes, it's the same on my side.
What's that? Can write something. If you have MacBook, you can also run this locally.
Maybe yes, I need to try to run.
Actually, I added just dropout and validation accuracy became better just by using dropout. I didn't expect improvement in quality, but it happened. Oh no, I also added one additional layer, dense layer. Yeah, it's not completely like that. Okay, so we got some result. Let's see evaluation results. It's 73%, a little bit higher. And see. So here it is obvious that at this point, we still have our improvement going on. So maybe somewhere at this point, we got some overfitting, maybe. But according to validation loss, it's not easy to understand where exactly, right? It seems to be at this point or at this point somewhere. Not really sure. Maybe even after ninth epoch. But here we still observe the improvement in quality. So in fact, this is maybe just a noise here in validation loss. Do you understand why we have this peaks and noise for validation noise graph and validation accuracy? Why for this epoch accuracy is a little bit higher than for this. Is there an idea?
Did you forget 50% after every epoch? Did you
No.
apply the drop?
No.
No.
The reason is that we during the training process, Keras framework, it splits data for training set and evaluating set differently. And this means that coefficients updates is done on a little bit different data set, but also we have some randomness. Yes, this dropout also influences this a bit. But even if you are not using dropout, you will see this peaks sometimes and noise. And the reason is that you have selected this validation portion for this data independently for each epoch. Okay, so theoretically, if we add some additional layers and dropouts, let's have additional dropout here.
So max pooling is the padding layer, right?
Yeah, actually, max pooling here is one of the convolutional layers of very simple convolution type. Max pooling takes matrix 2 by 2 and picks the pixel with maximum value. And the result is this value. It looks like this. We have 2 by 2. Here we can see 7, 15, 2, 2, 1, 197, and max pollen generates 2, 2, 1. It pulls the maximum value.
And it doesn't have to, and then what? And then it builds a new image with that value.
Yeah.
So, but do you need to pad it back out again, like you did with the other ones, or no?
No, it's like just what we do here is reduce the size of image twice as much for each dimension. So we have the picture like this, then we perform max polling and got picture like this size.
Yeah, I know, but do you have to do the padding for that as well? Or
we can and can not do this. It depends on our approach, and also it depends on defaults of framework. Yeah. Technically, we can also add some padding here, but this means that this is not informative part. For dropouts, it's not popular to add paddings because for not dropouts, max polling, because it is a lot of memory used for just not important part. But for general situation when we have convolutions, we just add 1 or 2 pixels here. It is not very different in matter of memory consumption, but instead we have still n by m. This makes us like we can use this size parameter all the time the same, not reduced each time. But for max pooling, if we reduce the size twice by x and twice by y, so we get 4 times smaller image. It is too much for paddings. Actually, do you see the whiteboard now?
Yes.
Oh, something weird that Zoom shows to me. Okay, we are training 25 epochs again, and I'll be back in a minute. Thirteenth. Almost done. Even better accuracy and some different type of behavior.
You show your screen again?
Oh, sorry, I thought you were seeing the screen. So we went through 25 epochs again. What we changed was we added for now 2 additional layers with dropouts. And for now, we got this type of output. There is a weird spike like this, but it is still okay. You will see this many times happening. So on such a short training, it's not easy to see the smooth curve because of noise here. But as long as we still have some improvements with validation accuracy, it seems to be okay. And we got even better accuracy for this network. So just by adding some additional layers into neural network, just regular dense layers, we can improve the nonlinearity and predictive power of neural network. But on the other hand, we have to train the network much longer, and it consumes more memory, and inference times is higher. So it is always trade-off between size of neural network and its quality performance. If we take a look at this description, you see here that we have already more parameters to be computed. Previously, we had 3.5 million, currently is 3.7, and each time we add layers, we increase this number. So for that part, I recommend you to experiment with dropouts and number of layers, and have some report on your conclusion about dropouts and extending this basic neural network. And this is actually a first part of report that we are going to make tomorrow. Tomorrow we will be doing several experiments, and final result of these experiments we will collect all together in one Jupyter notebook. It's going to be a new one, so you can create a first section in this Jupyter notebook with this architecture of neural network, absolutely the same part of Jupyter notebook, but experiment with several subversions of this neural network. You can try 1, 2, or 3 different additional layers like this. You can experiment with different values of dropout. It can be from 0.1 to 0.5, even sometimes 0.7. Also, you can just try, just for experiment, try sigmoid here instead of ReLU, and make a conclusion about your observation. Observation should be like, what's the final validation accuracy you got in different situations, and how long it takes to train the model. I'd recommend you to start this today, because tomorrow we will need more, we will be implementing other things also. You can do this in parallel with me while I'm going to talk about additional overview about generative adversarial networks. So I'll be I'll be talking about generative adversarial networks, but you can create Jupyter notebook in parallel, add this architecture there in several different forms, and run it. I will think that something is very important to write down about guns for now. I will tell, but now just um, create, please create new document, new IP1B file, add there several different variants of this neural network and run. And now I'm going to share a couple of links for generative adversarial networks. I have a question. Is it clear what to do now, or should I repeat?
I don't know what you're asking.
So you need to create a new Jupyter notebook now here in Colab. Copy the first part of this document there till this section. Actually, not till this section, till this section. And then repeat this neural network definition and running the training process several times with several different variants. Like you can use 1 or 2 additional dropouts there and different activation functions. I mean, sometimes you can use sigmoid instead and check what happens during. This is the first part of our report for tomorrow. So you can do this now, or you can do this later.
And using the same data set.
Yes, the same data set. The only thing you should be aware of is that all the time you run training process again, you should ensure that you run this line, like recreating the neural network object. The reason why it is important is if you don't create it again, you still have this object saved in memory with some coefficients already trained. So your experiment could be broken. So
you want it like, so you want a new model name every time, you mean?
No. The name can be the same. Just I think that it is better just to copy this code all completely all the time. So redefine. You can use the same variables, the same procedure of evaluation, like training and evaluation procedure. I mean, so this training process and this evaluation could be the same. If you want, I can explain this in words in our document. Actually, let me do this.
So it won't let me access. So when I mount the driver, it won't let me access the cats and dogs. No such file or directory, it says.
You should update your link according to your place where you stored it. So please open Google Drive link I've shared in document. It is called dogs and vs cats. Mount this thing into your Google Drive. If you open this link, you see the button add to your Google Drive. Do you see the link?
I'm opening now.
So
Yep.
when you open links to Google Drive, you should be able to see the icon that says that you can add this to your Google Drive. It will be like linked as a symbolic link to your folder somewhere.
It's link sharing. Anyone is link in view?
It's not sharing. When you see any folder in Google Drive, you can mount this folder.
It's in settings.
It allows me to add a shortcut to my drive or download it.
Maybe this is the option, yeah. So you can add this into your file tree and then specify a proper path instead of my line. So the line you will need to update is.
And that's what you did. How did you add it to your drive?
You know what? If I did to make a copy, it worked.
You made a copy.
Yeah.
It is important to do this using tools at Google Drive, because otherwise you will need to download it and upload it back, and it will take time.
Yeah, no. This is a tool in a command in Google Drive.
Yeah, Google Drive works well for that, I think.
Oh, there is an add shortcut to drive. Maybe this one.
Yeah, that's what worked for me.
It didn't work for you?
It did work, yeah.
It did work, okay. My drive, add shortcut. My drive. Is me.
So please ensure that you have access to these files. If you need help, please ask me. And while you are trying to do this, I'm adding some links about.
So it's in unzip, yeah? It's necessary to put here my link in a zip.
Yes.
Via get shareable link, I can copy the link.
Sorry.
How can I copy a link now?
So you want to write proper line here, right?
Yes.
Actually, you can try to ls to see the path by using ls utility, or in parallel you can go to the Google Drive, for example.
Yeah, it's not obvious how to get the path to a file.
Yeah.
Workspace, get shortcut. There's no like get a path function.
Go to here. Done. Yes, Python. So if you can see the screen, I just navigated here,
Yeah.
yeah, and found the path. So your path should be built like your drive folders hierarchy that you picked up for that, and my path is my drive, LL data, cures Python data sets. For your situation, it depends on where you mounted this link to. So
But is it possible to copy it, not to make it manually, but just to?
not sure about that. What you can do here in code, you can use Linux utilities, for example, like this. You can put exclamation sign and make ls. You can also cd somewhere. You can do cd, for example, train, and then ls, something like this. So you can use Linux commands, command line here. If it can help you, it is nice. If
Okay.
not,
Okay, it's easy. Okay. Share it with me, docs. Okay. Share it with me. Docs, okay. Test.
This is very frustrating. I've never had so much problems getting a path to a file before. Like it should be a trivial activity. It's like graphical user face for files is annoying.
And get shareable link. So actually it's the same. What is?
no.
But it's
Shareable
strange that
link,
you can.
shareable link is something that can be opened in web browser.
Yeah.
You pass the folder through user interface, but you need to have what? Just see. This couple of lines allows you to mount Google Drive to this mounting point in your collab infrastructure. Here you can see. So when we executed this couple of lines and provided access key, we created this link. This is not real folder. This is like mounted folder that contains all the data from your G drive. And here in this G drive, you can go down and find anything you have in your Google Drive.
Oh, that's a much better way, easier way to get a path.
Yeah, maybe.
Oh yeah. See, that's
it
like,
is, yes.
yeah.
Sorry for
Because using the graphical interface to get a path is stupid. All right.
But you know, nobody from Google engineers could think actually. Oh, you see that? There is copy path, but it is slightly different. You copy path, but you should understand that if I put it here, commanded one, just compare. It is almost like this, but not exactly. First of all, you should remove content here. And actually, you should also add slashes before spaces. It's like syntax for a command line. Just
This is ridiculous.
So this
This is it doesn't give good indication of what the rest of this exercise is going to be like if getting the path is causing so much problem.
yeah, I understand. But you still need to be able to like put the where did you mount your you can share your screen if you want, and I can
No, I'm just not, I'm just having to rearrange the slashes and backslashes and stuff.
yeah, but it's specific of Linux command line because what do you in fact do here when you put exclamation sign? You refer to Linux command line directly from this line. This is what would you write in Linux terminal. In fact, you are working on Ubuntu operational system here. And I selected now the thing that is completely Linux command line. So it is list the files in the folder that appears at this path.
Yeah, unfortunately, it's not. I run it and it says no. Cannot add. No, it says file or directory. Dog versus cats.
Okay, you actually, where did you mount this folder to? I mean, is it close to root of your Google Drive or
Yeah,
some?
my drive one up. Dog versus cats. The folders and dog versus cats.
So you can probably use a very similar path to mount.
Yeah. It just it's not going.
You can share the screen if you want. I will help you.
Yeah,
I
sure.
can stop sharing.
Where am I? So I have to authorize it to share my screen.
Okay, great.
Yeah, so here, my drive, dog versus cats. Boom, boom.
Okay, can you please right click on this dogs best cats and copy this path at first? Yeah, that's fine. Copy path. Okay, and yes,
We're here?
yeah. I think you should remove content here.
Yeah, I did that already, yeah, before.
Yeah, and could you please comment the next line, like this? Yeah. And before, after word copy and off, please put, yeah, try it. No such file or directory. Could you please like remove everything after G drive and run the thing? Oh, remove the slash before G drive. Yeah. Well, then write my drive with a backslash.
Okay, so
Yeah.
Boom. Good.
Yeah, so please update all other. Okay, it installed at the next.
Right. Okay. All right. Thank you.
How can I see you mounted your Google Drive to the callout?
You can also share the screen like,
Uh,
if you want.
yeah, sure.
Cool.
Do you see it?
Yes, I see. Oh, please click the link. It shows the link.
This one?
here. Yeah. Allow permissions with this account. Yeah. Scroll down. Copy this line.
If I open book, copy of copy. Okay, I copied it and now need to put it somewhere here. Or mount drive. Alexander? Alexander left. What is the data? Что, Семен, у тебя получается?
We are almost data scientists. This is the distance, remaining distance.
Oh yeah.
Just to find a way to log in Google Drive.
What is the data?
А там же кнопочка скопировать сбоку.
Это.
Угу.
А куда его вставить? Сюда в коллаб где-то надо вставить.
Я пробовал вставлять в коллаб, у меня вставилось, но потом что-то дальше говорить все равно не хватает чего-то.
Where shall we put this code, Alexander? Strange.
Sorry guys, something has happened to Zoom. I had to reboot. Do you hear me now?
Okay.
Да.
Yes.
Yes.
So where shall I paste this code?
Is there any sound available?
We hear you.
Guys, do you hear me?
Yes.
Yes.
I don't hear you at all. Cannot hear. Just a moment.
Kenneth, where did you copy this?
I
Oh,
so please copy this thing. Okay.
and go back to your.
Yeah.
So when you run that, when you run the mount command,
Yeah.
it'll ask you for it. So you got to run that
This.
first.
Yeah. Yes.
Yeah.
This makes. But now you will get no link again.
Мгм.
It is like dynamically generated. Could you please restart your runtime? Something is going on with your like runtime and reset
Restart.
runtime. Right. Yes. Run all the things from the beginning. Like scroll up.
Run all.
No. Oops. Okay. Let's see. Run all. Copy the link. Like navigate the link and copy the value. Not like this. Please close this. Close this. No. Not. Please don't copy. Just close the page. Go to the notebook again. Click the link again. Like accounts, google.com, blah blah blah. It will regenerate the access token. Yeah. Copy it. Yeah, it works. Go back. Enter to this field. Enter your.
Okay, there is input field.
Yeah.
Oh my God.
Enter. So here cannot access. It's okay.
Yeah. So
all
now I
other,
shall.
you should.
Where is it?
Oh,
I
So
don't see it.
it says cannot access, but it is okay?
it is okay because he hasn't updated the line yet.
Yeah.
Oh,
But I don't see this here, the mounted drive in the browser.
Refresh files. Somehow you got to the root of file system. Let me check how to go inside. Then
Disk. etc.
ooh.
yeah, please learn how to do this. It's important.
Root. So this is a Linux file system, yeah.
Yeah, it is. So I'm trying to find the
Usability is. If I see here, why I don't see it here?
yeah. I
Files.
will find it for you now. Just a moment. Okay. Enter the content folder. Content folder.
Content
It is the
folder.
third one. Yes.
Okay. My drive.
Docs and vs cats right click and copy path. Yeah.
Copy paste.
Then go to the
Try. It's for,
no,
it's
just
for
docs vs cats. You need entire folder maybe. Oh no, sorry, you did correctly, and replace the line.
Okay, this one. Yeah?
Yes, it is. It seems already to be updated, but try updating again. I want to be sure that you complete path after unzip. Remove everything. Yeah, like this. Run.
But I need these backslashes.
Yeah, yeah, and
My
run.
drive.
So I'm getting, oh, I'm now getting
Yes.
runtime errors.
You got an error too?
A runtime error for multi-backend Keras that does not support TensorFlow.
We will fix that. Please don't worry. Um,
My drive.
Use ls for this path. Copy the first line, like unzip and blah blah blah.
Copy first line.
Yeah, copy complete line and
This one.
yeah,
Мгм, да.
comment this one. I just want to preserve it in commented line. Paste. Comment this one. No, just okay, and use ls instead in second line. ls and remove train zip at the end. Yeah.
Okay.
Run. Okay. Remove dogs vs cats here. Run. Okay, so it cannot access.
My
Okay,
drive. Maybe here some extra.
maybe no, maybe it requires maybe working folder for you is root now, so maybe you need content.
Full pass, yeah? I need full pass.
Yeah, yeah.
Pass.
Remove also G drive, ls and full drive. Yeah, remove, yeah? And paste. Run. Add slash and run. Yeah. Great, it works. Add path segments after my drive. Yeah, you can add this dogs vs cat there. No.
You mean like this?
Yeah.
But why we have different behavior? Okay, yes, it's working.
For some reason, you moved to root of file system. I'm not sure why. I didn't see everything you did here. Go button. You already have. You don't need to run seventh thing now because you already mounted on Google Drive. Please run ls. I want to see to ensure that you have the same structure there. Okay, you can proceed further. Proceed to the next. Yeah,
I mean, to run this?
yeah. Yeah, run. This is installs a special utility called tree, and it is able to show the file tree. So yeah, you have correct file structure. Run cell by cell. You can press Shift Enter.
how to shift enter. Shift enter, shift enter, shift enter.
Enter. No, we shift enter. Go to the very beginning of the file. For some reason, you don't have some. Okay, I see. The reason, not sure why, but before import keras, please put the line like this. See the document I've shared. I added as the last. And you can please do the same. For
Is it
all,
a blank line that says?
no. Add before keras, import keras.
Yeah.
Add the line. Let me show you. I will share the screen.
Because I listening to downgrade.
Yeah. Because Google recently switched to TensorFlow 2.0 from to be used by default.
Yeah.
We have to verify that it is still the first version of TensorFlow.
Okay. It also says, as I'm looking at Stack Overflow, it says that you can use 2.3 keras instead. You can also upgrade keras instead of downgrading.
Yeah, it is possible, but this is the easiest way for now because keras has a slightly different API and could behave differently.
So what's the line? Could you show me then the line?
Yeah, please take a look at document with links. The last line.
This GitHub?
No. Let me.
Ah, okay. Now I see it. TensorFlow version. Okay.
Yeah, it's this is the thing that should be at the very beginning of the document.
Okay, so then we just need to restart the runtime then. And
Yeah. And be careful when you will be unzipping files again. They are already there, and a system will be asking you overwrite files or so. So just
capital N, no, none.
So tomorrow we are going to run several Jupyter notebooks. So it's important to understand how to use them now. I understand that this mountain things kind of not convenient thing to do, but you should familiarize with that to proceed with the experiments. Because alternative we have for that is running Jupyter notebooks locally on your system and dealing with all the problems that will be caused by different operation system and so on. It is much easier to understand how to mount things in Collab.
Yep, no, I can see the advantage of that. Then we're all on the same system too.
So my turn, no?
Now it doesn't want again.
I can keep on building.
Unzip content. Unzip content.
If you have any questions, please share the screen and we'll be solving the problem together.
Yeah, I have a question. I have the same question. So,
so what exact question? Do you need this variable before? Just share the screen.
Yeah. What I should do? What I should push to share the screen? Share the screen. Okay. Share.
first of all, go to the very top of the document. And before import queries, input this line, TensorFlow version 120.
This one.
Yeah. Okay. And then to be sure, just relaunch runtime, because if you already executed something, it can be restarted runtime. Yeah. Once it is restarted, you'll be able to run this again, run, and go further. Great. Shift enter, and do this.
All right.
Mounted.
Yeah, you still have the same.
Mounted.
You need to update the path. So go to the file system, left menu.
Here.
No, folder sign, like down.
This one.
Yeah. Go to G drive, my drive. Find the okay. Where did you mount it to? Not
So this is the notebook we are working in.
Yeah. All these notebooks are stored here, but you need to navigate to folder. You add it to your. Did you add the folder to your Google Drive?
No, I just follow the instruction.
Go to the links document.
Links. Okay.
Scroll. Yeah. Docs vs cat link. Click those. Yeah. Just click
This
it.
one.
Yeah, navigate it.
Okay.
Yeah. Drop down menu after docs vs cats.
Drop down here.
No,
Here.
Yeah. And додати ярлик на диск.
Yay. Me disk. Додати ярлик. Додано.
Let's go back to, yeah.
So you want us to play around with the section before the data augmentation section, correct?
Sorry. Oh, yeah, for sure, yes.
So don't worry about data augmentation portion.
Yeah, you don't need it now.
Okay, all right.
So right click on the folder, just right click on it. Copy path.
Mm-hmm.
And insert this path before docs vs cats. Yeah.
Here.
Oh, all the line, like.
All the way.
Yeah, all the line. Remove. Oh yeah, it's okay. Run. You forget put backslash before space after my before drive. No,
Like this.
Before space, remove the slash. Remove the slash.
This one.
No. Like, yeah. Remove this one. Backspace. And put it after word my.
Here.
Yeah. Run. Okay. Now you see the content of this folder, and you got that run this. You also need to update this path for unzip.
Unzip. So I should put the same.
Yeah, copy this thing completely.
All the line.
all the line, but also please don't forget when you will be pasting it, like go to unzip instruction.
So I understood that I should copy this part and put it instead of this part.
Yes,
Yeah.
kind of that, yeah.
Like this?
Yes. So you get your files unzipped.
Laura, thank you very much.
Alexander, I still have this runtime error. Module TensorFlow has no attribute get default graph.
Did you relaunch the environment runtime?
No.
You should relaunch.
Restart and run only. Okay.
Yeah. Restart and run from the beginning there. So fine. Yeah, it is already completed. Go. Okay.
Perfect. Super. Mm-hmm.
Okay.
Круто.
Here you have to build your network. Actually, try it.
Try?
Yeah.
Okay.
Scroll down. Run model summary.
Mm-hmm. Super.
Then go down.
Next.
Yeah. It's okay. Go down. Yeah, you need to open this, run this, go down, run this, scroll down, and actually here you start your training process. If you check please runtime type, go to runtime menu. Oh, it seems to be using GPU. It computes pretty fast.
I should go to runtime just to see.
Yeah, like
Yeah, this is GPU.
Yeah, just not ensure.
Mm-hmm. Okay, thank you. It seems everything worked for me.
Yeah, also for me, it worked.
Okay, so what you need to do is to run evaluation thing here, see the output picture, like curves, how training curves, and then
I can't see anything.
Sorry?
I can't see anything here.
Yeah, I stopped casting my screen. And I'm casting now again.
So this is done. Run next one. As you can see, actually, in this block, you're going to run now. Like you see model save and model load. You get your model saved into H5 file just for potential usage in the future. Run the cell. Yeah. So accuracy. Yeah. Let's run further. So this is the set of curves you get. So after that, you can just remove everything. Others, you need just this what you already went through. You don't need any
Okay.
more. And now you can add below or edit the neural network definition and epochs number here and rerun it 5-7 times with different hyperparameters, including adding dropout and so on. In like, yeah, you can put 25 epochs here just to see how the process goes. And one interesting thing that you're doing now, you are not training from the beginning now, because
Да, точно.
yeah. So you should understand that in fact it was 10th epoch. Yeah. So
Yeah, I should rerun from the beginning.
Yeah, I hope that it is clear for now. I want you guys to experiment with this and run and make it clear for you, because all the experiments later will be kind of the same, and it is also important for upcoming course with natural language processing. So it's generally you cannot try anything in machine learning without doing this type of operations. It is possible, like, not to dig deeper, because we have many examples of implementations from other people. We can copy their solutions, but we still need to be able to put proper paths, mount folders to Google Drive, and so on.
So we will need to restart from this here, from this point, correct?
Yeah.
But
so,
but here I do not see the drop line.
you can add dropout.
Dropout.
Here, let me share with you how it looks on my. You can add this couple of lines one or more times after flatten instruction. Please take a look at chat window.
So why after the flatten instruction?
Actually, it ensures that you have one long vector there. Before this point, you work with a thing that technically can be represented as an image. All the convolutions you are using, it's kind of the set of filters you apply to image. And this type of filter implies that you have your data preserved in initial shape, like lines and columns, so it is still rectangular. But after this point, we are going to use dense layers for neural network. And it should get just a plain vector as an input. So flatten makes this data to be like one flat vector in one line. This is actually a reshape operation.
But in this part, I mean, at the beginning of build of our network, This is the this part of code if I may. I don't.
If you want
Share,
to
share the screen. Mhm. Share. So I mean, this part of code, it describes one epoch.
it describes the structure of neural network.
Okay.
Sequence of layers in it. The first instruction, it creates the object of a neural network in terms of Keras framework. And then all the add instructions, you add different types of layers to your neural network.
Okay.
Yeah.
But it means that to know how many layers, how many hidden layers, I should calculate 1, 2, 3, like this, right?
Yeah, the only one layer that isn't hidden here is sigmoid one.
The last one.
Yeah, and you have just one output there because we need just one decision, 0 or 1, and a sigmoid provides such a thing. So you can put dropouts after each dance also.
After each dance.
Yeah.
And I should not flatten again.
No, it is already flat.
Because it is already flat.
Yeah.
Like this.
Yeah. Actually, for the last one, you can avoid it because it won't make any sense. It's just from experience. You can comment this.
Okay.
Yeah, and try.
Okay. I should restart because.
Actually, no, I don't think.
Because there is some processes are running below.
Okay, yeah, I understand.
So then I will run everything up before.
Yeah. Please navigate to the very top of the document. Yeah.
Okay.
It awaits for your input. Please put A.
A.
Yeah, capitalized A. Oh.
Okay.
And then we plot it. We plot the training, validation, accuracies, and losses, and then we're good. Correct?
Yeah, you plot them and see like details how this process went. Generally ideally what we want to get there in most situations is something like loss should be going down, accuracy should be going up, and almost reaching the 1 and so on. But in fact, we will get, first of all, something like this. And generally, in many cases, if process doesn't converge, we can get something like this. It is wrong situation.
You should show you should share the screen.
Yes, we don't need to see some end screen anymore.
Да.
you can ignore all the warnings if you get some warnings. Warnings, it's okay.
Sorry?
I mean, if you see any warnings, it's not a problem.
Yeah, they're just like syntax warnings.
Not like this. They also try to inform you that something is going to deprecate it in upcoming versions, or maybe API has already been updated and you can use a newer version of API, something like this.
Yeah, yeah.
If it is still warning, it means that your code will work well. Just be aware that in upcoming versions it can become not working. Also, I'm going to show to you one interesting demo application from NVIDIA.
Share screen, please.
Yeah. So what we need also to talk about is generative adversarial networks. And one important thing about them, that this is a good example of unsupervised learning. And for images, it is like a core thing for generating new pictures. You might remember the program called Prisma for iPhone and Android. Do you remember that? Like you can apply some style to existing photo, like make your photo to be painted in a way how potentially Picasso could do, or something like this. Also, you might know many applications that change the style of your face in different ways, improving the quality of photo, or maybe applying some weird filters to the face, including what Facebook does, Facebook Messenger does. All these features are available because of generative adversarial networks. It's quite a complex part of machine learning and computer vision and image processing, but it is still something interesting that you can do. So now you see the screen, and we can come up with some very simple pattern here and generate some landscape. And it can be like, let's an embedded page, or it says something, terms of conditions. Somewhere there is a terms of, this is a checkbox. So this is a demo, and NVIDIA asks me just to, so currently I clicked the button, and system has generated a landscape. It did this because we specified that at the bottom we have water, at the top we have sky. But we can edit this a lot. Like, for example, I want to add some clouds here, and I just take brush tool and draw something here. Yeah, and let's check how it is going to be regenerated. Also, maybe I want to have mountain here in, maybe I want to have a rock here. Oh, we have also a kind of rock. So let's use rock. I don't have mouse now. It's like track point. It's not convenient to use. Sorry. So we have something like this, and I want to have a rock inside the ocean. In addition to that, I want to maybe pick up some sand here because it is nice to have a nice beach by the rocky seashore. And let's check what's going to happen. So take please a sandy seashore with rocky mountains there. So this is generative model. There are many generative models in any domain we can use, like audio, video, image, or text domain. All of them can be really nicely used with generative networks. And this is a quite nice example. Let me actually share it with you. You can play with it. Oops, sorry. We will be discussing guns further, but now you can just plain understand what things it can.
What's the adversarial part of an adversarial network?
Yeah, this goes down to generally there is a theory in computer science and artificial intelligence called game theory. And we have many types of games we can play, but some of games can be called adversarial games. For example, chess is a type of adversarial games, and the main definition of adversarial game is if you want to win, the only condition you win, your opponent lose. So you, as a player, you are trying to optimize the gaming process to get reward to you and get provide penalty to your opponent. And your opponent tries to do opposite thing. So this is a condition of winning. Your opponent should lose. And this is the place where we see this adversarial part. And generative adversarial networks, they do almost the same thing. They are trying to, they consist of two parts, two different neural networks that they are trying to play the game in a opposite way. I will explain this in more details tomorrow when I'll be talking in more detail about adversarial networks. But the general idea is like that. So two neural networks are trying to compete between each other. One neural network does one thing, another tries to do another thing. And primarily, this process is happening during the training process. This is the optimization process that we have during training. But when we already have this thing trained, we need to have just one pass, generative pass. So it is a little bit different from what is happening during the training process. Yeah, actually, like that's it about a house. Let's add a small house to this pitch. I just can't imagine. So it looks like some type of house. Little bit less sand here, but it is still house. We can also add some additional roof here, maybe. Not ideal, but no.
It is losing.
No. Let's have some flowers here. Okay. So I think it is still quite impressive thing, because what is happening in fact here is neural network dreams of something and generates complex pictures. Sometimes we can generate very, very nice pictures and even photorealistic ones. For example, let's say, oh, let me write another couple of examples. You will like it. Let me check. Faces generator. Actually, it's new. Uh, epoch comes to porn industry, because currently Pornhub has developed a new type of neural network that can completely generate new porn actress and make her act absolutely in absolutely photorealistic way. It's a reality of nowadays.
Finally.
Yeah, actually, this is a very interesting fact that this type of industry uh, appears to be like something that makes progress go further. For example, here in Kiev, we had a conference about artificial intelligence and machine learning, and one of engineer from this company came to Kiev. Unfortunately, it is illegal in Ukraine to advertise and even mention companies that distribute porn content and any content for adults. And he had to like remove all the labels from his presentation. But the thing is that internally in company, they use very modern approaches and sophisticated algorithms and nice engineers to move the technology further. They even have many publications in scientific world, and you probably will see many achievements, technology achievements that were created by them. Yeah, they spend huge money on this.
It means feel as a god, yeah.
It's
To create something.
But yeah, but some step.
Yeah.
Another profession which will be replaced by robots.
Yep.
Not by robots, but by AI. The oldest profession, by the way.
What's number 2?
Lawyers.
Why
Web
number 2?
browsers.
What is number first?
I don't know.
So actually, I found a collection of interesting examples about generative networks for you here. It's the list. The link is already in document. So let's check what we can generate with adversarial networks. I really like this one. I hope we'll be able to run it. No, it's just an article about that. Where is implementation? So here you can create a sketch of bag or maybe shoe and get generated image. In our professional field, we already used this one. So you can get a satellite photo and generate complete Google-like map with some accuracy. It's not perfect, so that we cannot use just solve our problems for our project, but some achievements we can get from here. So you can see satellite photo and see almost perfect roads network, right? Web of roads. Actually, you can also try this one. For all of these things, you can find online demos. You can try most of them.
You put a link to this already? Yeah.
Sorry.
There's already a link for this. Yes.
Yeah. I already put it, but the thing is that I wanted to find interactive demo, not just screenshots. There are some available. Actually, you can. Actually, image to text translation is something impressive. You can put an image and system generates a textual description about what you see on the picture. Of course, with many mistakes and errors, but you can easily get something if you send a picture of a dog walking outside. You will get dog walks on the lawn or something like this. Sorry, there is a misprint here. So is it clear for everyone how to launch this Jupyter notebook? Should I help someone?
No,
Yes.
Thank you. Now it's
So for tomorrow, we will leave generative adversarial networks discussion. I think that for business, they are very hot topic. Many new different solutions already released but many. I think there are many room for new startups using generative adversarial networks, and also we will try some examples of neural networks. I think that when we finish tomorrow, we will have like good draft of report document, something you can submit for the course. And also you will have the set of links and books recommendations for if you want to learn something more. Yeah. For today, I think it's over, but I still can help with running examples if you want.
For me, everything works.
Yeah,
Thanks.
So
to me as well.
please continue experimenting with this Jupyter Notebook. Try at least several different versions of this neural network. Add some layers, remove and add dropout, and make a conclusion where you get better result. And also play with sigmoid and ReLU activation functions. Oh, sorry, I forget that I have my video off. Sorry. So, do you have any questions for now?
Don't we have now this, let's say, structure of neural networks in the document, some kind of lection material?
Actually, we have several links for proper books about that with similar architectures and explanations, and also maybe I can find some additional my own materials about that. I think you can try links to books now in syllabus. They are available in syllabus. You can check. But for tomorrow, I will provide additional set of links.
Okay, thank you. Just to have some, let's say, overview, yes, of what we try, all these combinations, that to understand what is behind, yeah, what not in to make in blind mode.
It's a very interesting topic, and we can talk a lot about like how optimization process goes, how works, like how dropout works, how different activations work, and it is very interesting. But unfortunately, in order to do this, we need to spend at least whole day for discussing like activation functions and their behavior. If we try doing this, we will miss the overview, because I think that you can read some details later, but if we don't discuss generative adversarial networks, it would be a big loss for like our overview. Okay, thank you guys. We can continue experimenting, and let's meet 9 a.m. tomorrow.
Okay.